Hello students, in this video you are going to learn MCQ questions from NEET practice set 1, that is question number 21 to question number 30. Now coming to question number 21, so after reading question you will understand that the solvent will be carbon disulfide because sulfur in 100 gram of CS2 is given. That means it is dissolved in carbon disulfide, that is it is solvent. Therefore solute will be what? Sulfur. Solute will be sulfur. So what are the given information they have given? So for sulfur means mass of the solute WO2 will be 3.795 gram. Then 100 gram CS2 means mass of solvent is given, that is 100 gram. What is given? Boiling point of this solution. When sulfur dissolved in CS2, it boils at, that means boiling point of solution means symbol TB. So that is they have given 319.81 Kelvin, that is a boiling point of solution. Then boiling point of CS2, that means boiling point of solvent is given. It is represented by the symbol T0B. So that is 319.45 Kelvin. Then Kb value for the solvent is given, that is 2.42 Kelvin kg per mole. What they are asking? Molecular formula of the sulfur. So molecular molecular formula of the sulfur you have to find out. So to know the molecular formula, we have to find out molecular mass. So first we are going to find out molecular mass, that is M2, molecular mass of solute. With the help of that we will find out molecular formula. So first we will calculate delta TB, that is elevation in boiling point. So formula, boiling point of solution minus boiling point of solvent. So solution is given 319.81 minus boiling point of solvent is 319.45. So if you find the difference, so the difference will be 0.36 Kelvin. So now after this, you to calculate M2, use this formula, that is molecular mass of solute M2 is equal to, so WO2 divided by WO1 into Kb divided by delta TB into 1000. Now you substitute the values. WO2 value 3.795, WO1 100 gram, Kb value 2.42, delta TB 0.36 into 1000. So after calculation you will get molar mass of the solute M2 as 255.1 gram per mole. So this is the molecular mass of sulfur. So now they are asking molecular formula. So to find molecular formula we require number of sulfur atoms. So therefore number of sulfur atoms in a molecule can be easily calculated using this relation, that is molecular mass of sulfur divided by atomic mass of sulfur. Atomic mass of sulfur. So what is the molecular mass of sulfur we have calculated in the above step, that is 255.1, and atomic mass of sulfur, so you know that sulfur atomic mass is 32. So if you divide these two things, so you will get 8. So number of sulfur atoms in a molecule will be 8. So therefore molecular formula of sulfur will be S8. So option number C correct. So question number 21, option C is the correct answer. Okay students, coming to question number 22. Osmotic pressure of 10% cane sugar solution at 69 degrees Celsius is. So they are asking osmotic pressure. Osmotic pressure symbol means what? Pi. What is the meaning of 10% cane sugar? So cane sugar means sucrose. So 10% sucrose solution. So that means 10 gram of sucrose, 10 gram of sucrose dissolved in, so dissolved in 100 ml of solution. That is the meaning. Percentage means 100 ml. Dissolved in 100 ml of solution. So therefore, here the mass of the solute is sucrose. How much? 10 gram. So volume of the solution will be what? 100 ml. So temperature is given in degree Celsius, that is 69 degrees Celsius. Convert into Kelvin by adding 273, or you can add 273.15, no problem. So it will be 342 Kelvin. Next, molecular mass of sucrose. Here sucrose is a solute. That's why molecular mass of sucrose, solute, is represented by the symbol M2. So sucrose molecular mass 342 gram per mole. In the problem they have not given, so you have to calculate what? Sucrose molecular mass. You know that sucrose formula is C12H22O11. So if you calculate molecular mass of this, so it will be always 342 gram per mole. Next, after knowing all these things, you substitute in the formula. So you know the formula in osmotic pressure concept. We use this formula. What is that? M2 is equal to, that is molar mass of solute, is equal to Van Ta factor into WO2 RT divided by pi into volume of solution in ml. If volume of solution in ml, then you have to multiply with what? 1000 in the numerator. So now we want pi, osmotic pressure. So you rearrange the equation, you will get I into WO2 into RT divided by M2 into V into 1000. So now substitute the values. So since cane sugar is a non-electrolyte, that is sucrose is a non-electrolyte, so Van Ta factor will be 1. So will be always 1 for sucrose, glucose, etc. So WO2 they have given. So what is the mass of the solute here? 10 gram. So R value, gas constant. So yourself you have to remember and write, because in the problem they have not given 0.082. That is gas constant. So of course temperature in Kelvin, that is 342 Kelvin divided by M2, molar mass is 342, and of course volume, that is 100. So after simplification you will get the pi value. So here 342 cancels out like that. You simplify, pi value will be 8.21 atm. So 8.21 atm, it is there in option C. Therefore question number 22, option C is the correct answer. Okay students, read question number 23. So again they have given volume, temperature, mass of the solute is given, osmotic pressure is given. So they are asking molar mass of solute. So same formula that we have used in previous question, same formula we have to use. So what is that formula? M2 is equal to I, Van Ta factor into WO2 into RT divided by pi into volume in ml. Centimeter cube means ml, milliliter or centimeter cube, both are same. So into 1000. Now substitute. They have not mentioned anything about solute, that's why Van Ta factor is taken as 1. WO2, mass of the solute, that is 4.34 gram. R value as usually 0.0821. Temperature in the problem directly they have given in terms of Kelvin only. No need to convert into Kelvin, that is 298 into 1000 in the numerator. So divided by osmotic pressure 2.55. So volume in ml is given 1000 cm cube, correct? So 1000 cm cube. So here 1000 cancels out. So like that, if you simplify it, finally you will get the molar mass of solute as 41.63, and of course unit will be always gram per mole. So unit will be gram per mole. So the correct answer 41.63 gram per mole is there in what? Option C. So correct answer for question number 23 is option C, 41.63 gram per mole. Coming to question number 24, again this question is also on osmotic pressure. So in this problem they have given glucose as the solute and dissolved in 100 ml of solution and temperature is 298 Kelvin. So they are asking osmotic pressure. So direct formula, osmotic pressure pi is equal to I into WO2 into RT divided by M2 into volume of solution in ml. If volume is in ml, so multiply 1000 in the numerator, correct? So Vanta factor glucose, that is 1, WO2 mass of solute 5 gram, R value they have given 0.0821, temperature of course 298 into 1000 divided by molar mass of glucose. So what is the molecular formula for glucose? C6H12O6, correct? So if you calculate molar mass of this glucose molecule, that will be 180 gram per mole. So in first PUC, so you know that the molecular mass of glucose, you know how to calculate. So you studied that in first PUC. So now substitute that here. What is that? 180 into volume will be 100. So now after simplification, so the value will be 6.79 atm. So atm, atmosphere pressure, is unit of osmotic pressure. So 6.7 means approximately it is in option C. So therefore question number 24, option C is the correct answer. Read question number 25. For the graph of pi versus C, pi means osmotic pressure, C means concentration at temperature T, the slope is represented by. So remember osmotic pressure formula, that is pi is equal to CRT. So now I will rearrange this formula like this. Pi is equal to RT into C plus 0. So if you add 0 to this, so the value will not change, correct? So now I am going to compare this equation with equation for straight line, that is y is equal to mx plus c. So what this m is called as? M is called slope of the graph. So this c is called y-intercept. Y-intercept. Suppose if you plot the graph, so by taking osmotic pressure along what? Y-axis and concentration along x-axis, C along x-axis. So y-intercept 0 means the graph will start from origin and it should be equation for what? It's matching with equation for straight line. Therefore you should get a graph of a straight line, so starting from origin. So now what is the slope of this graph? That is slope of this graph, that is m. So that is m is what? RT. So slope of this graph will be RT. So therefore option C correct. Question number 25, option C. Now read question number 26. So what it states, 17.8 gram per liter of cane sugar. So cane sugar means sucrose. 17.8 gram per liter. What does it mean? That means 17.8 gram sucrose dissolved in 1 liter of solution. That is the meaning, because gram per liter they have given. So therefore, so what will be the weight of the solute here? Weight of the solute WO2 will be 17.8 gram. So what will be the volume of the solution? So volume of the solution, so this is given in liter, that is 1 liter. And they have given osmotic pressure. They are asking what? Temperature. And of course molar mass they have given in the question itself, that is M2. So we use same formula, that is osmotic pressure formula. What is that? M2 is equal to I into W into RT. W means WO2, mass of solute, divided by pi into volume in liter. Since volume is given in liter, no need to multiply 1000 in the numerator. Okay, so now directly substitute. So M2 value will be 342. Of course, for sucrose, Vanta factor I value is 1. W2 they have given, what is that? 17.8. And of course, R value, you know that 0.0821. It is a constant value, you have to remember. So you have to find out temperature. So divided by osmotic pressure, they have given 1.2 and volume in liter is 1 liter. So after simplification, you will get temperature as 280.9 Kelvin. So in Kelvin you will get, because we have substituted in what? SI units. So therefore option C is the correct answer. Question number 26, option C. Okay students, coming to question number 27. So in this question, so they are mixing two solutions, 0.4% urea solution, and it has osmotic pressure 1.66 atm. Another one is 3.42% sugar solution whose osmotic pressure is 2.46 atm. So when these solutions are mixed, what is the resultant osmotic pressure? Resultant pi. So remember, whenever two solutions having different osmotic pressures are mixed, so you can use this formula. So that is for solution 1, osmotic pressure pi 1 V1 plus for solution 2, osmotic pressure it's pi 2 and its volume is V2. So that should be equal to say final osmotic pressure, that is pi F into, so volume will be obviously V1 plus what? V2. So initial volume V1 and V2. If you add these things, you will get final volume. So now we want final osmotic pressure pi F. So therefore formula becomes pi 1 V1 plus pi 2 V2 divided by V1 plus V2. So now what is the first osmotic pressure? 1.66. What is V1? So V1 they have not mentioned directly here. You read this question. 0.1% urea solution, that means 0.4 gram urea in 100 ml of solution, that is the meaning. Similarly 3.42% sugar means 3.42 gram of sugar means of course sucrose in 100 ml of solution. So therefore urea solution volume is what? 100. So V1 is 100 plus pi 2 second osmotic pressure 2.46 into V2 means sugar solution volume, that is also what? 100. So divided by denominator, V1 is 100, so V2 is also what? 100. So 1.66 in the numerator you can take 100 as a common factor. So 1.66 plus 2.46 into 100. So divided by 200 in the denominator. So 2 zeros cancels out. Then you simplify that. Finally you will get the final or resultant osmotic pressure as 2.06 atm. So 2.06 is there in option C. Therefore question number 27, option C is the correct answer. Now you read question number 28. So in this question they have given osmotic pressure, pi value is given and temperature is given as 37 degrees Celsius. You convert this into Kelvin. So after converting into Kelvin, so you will get this as 370 Kelvin. By adding 273 you will get 370 Kelvin, and then 6.8 into 10 power minus 3 kg of protein. That means this is the mass of solute protein dissolved in how much of volume? 10 power minus 3 meter cube. So this will be the volume. Okay, now you have to find out molar mass of protein. That means you have to find out M2. So that is a question mark. So now you write the formula. So M2 is equal to, as usually, Vanta factor I W2 into what? RT divided by pi into volume. So here volume is in meter cube, that is SI unit. So no need to take 1000 in the numerator. So now substitute. So protein means it is a non-electrolyte. That's why the Vanta factor is 1. So W2 is 6.8 into 10 power minus 3 kg. R value, That means they have given in terms of kg, meter cube, pascal, correct? They're all SI units. That's why R value should be in joules. That's why it is 8.314 you have to take in this case. And of course temperature is 370. Osmotic pressure they have given 3.02 into 10 power 3. Then volume is given 10 power minus 3. So 10 power 3, 10 power minus 3 will cancels out. Then you will get M2 will be 17525.9 into 10 power minus 3 in the numerator divided by denominator 3.02. So further simplification, M2 will be 5803.2 into 10 power minus 3. Now you can shift the decimal to the left side. So 3 digits we are shifting to left side means plus 3. So this plus 3 and 10 power minus 3 cancels out. So final answer will be 5.803. Since we have substituted all in SI units, so that will be kg per mole. So option number B. So make correction in option B. They have given 58.06. So correct answer is 5.806. There is a typing mistake here. So therefore question number 28, option B is the correct answer. Now coming to question number 28. So in this question they have given osmotic pressure pi value in terms of Pascal, 37 degrees Celsius, that is temperature is given. So if you convert this into Kelvin, so that will be 310 Kelvin. So that is osmotic pressure is given 3.02 into 10 power 3 Pascal. Then temperature converted into Kelvin, 37 plus 273, you will get 310 Kelvin. And then mass of solute, that is protein, W2 is given 6.8 into 10 power minus 3 kg, and volume is given 10 power minus 3 meter cube. The molar mass of protein in kg per mole they are asking, that is M2. So what is the formula? So M2 is equal to I into W2 into RT divided by pi V. So since all are in SI unit, we are not taking 1000 in the numerator in the formula. So I value protein, it is a non-electrolyte, so Vanta factor is 1. W2 mass of protein, that is solute, 6.8 into 10 power minus 3 kg. R value 8.314 joule per Kelvin per mole, and temperature 310 Kelvin divided by pi value, osmotic pressure 3.02 in 10 power 3 Pascal into volume is in 10 power minus 3 meter cube. So now you simplify it, 10 power minus 3 and plus 3 cancels out in the denominator. Then per Kelvin and Kelvin cancels out. In the numerator you left with kg into joule into per mole. In the denominator you left with Pascal into meter cube. So remember, Pascal into meter cube is nothing but joule. So this joule and joule cancels out. So final unit will be kg per mole only. So next, after simplification, the numerical part. So you will get 5.803. So therefore final answer is 5.803 kg per mole. So in the given options 5.803 is not there. So please make correction for second option. Instead of 58.06, you make it as 5.806. So therefore correct answer is second one. So 28th question, option B is the correct answer. Coming to question number 29. So you read that osmotic pressure is given at 300 Kelvin for solution. so which contains 1 mole of solute. Similarly, another solution whose osmotic pressure is given at the same temperature and that contains 1 mole of solute and its volume is given. So what is the unknown volume of first solution? So you know that volume and osmotic pressure things, the formula is pi V is equal to nRT. So this is the formula. For solution 1, you can write the formula as pi 1 V1 is equal to N1 RT. R is gas constant, T is temperature. Since same temperature is given, therefore we are not writing T1, simply it is RT. Similarly, for solution 2, formula becomes pi 2 V2 is equal to N2 RT. Since both solutions are taken at the same temperature, so you can equate them. So pi 1 V1 is equal to pi 2 V2. So pi 1 V1, remember that is you have to take N1. So since N1 is 1 mole and N2 is also what? 1 mole. So therefore RHS, right hand side, becomes equal. So therefore you can equate LHS. So after equating LHS, so this will be the formula. Pi 1 V1 is equal to what? Pi 2 V2. Now we have to find out the volume V1. So pi 2 V2 divided by what? Pi 1. So now you substitute. Pi 2 is 2.82 into 10 power 5. So V2 is 10.5 divided by pi 1 is 3.90 into 10 power 5. 10 power 5, 10 power 5 cancels out. So finally you will left with 7.59 meter cube. So this is the answer. So 7.59 meter cube is an option A. So 29th question, option A is correct answer. So read question number 30. 30 gram of glucose in 1 liter solution, aqueous solution, has osmotic pressure 4.9 at 303 Kelvin. So osmotic pressure is given as 1.5 atm at same temperature. Then concentration is, that means one osmotic pressure is given, another osmotic pressure is given, they are asking concentration. So you know that osmotic pressure is always directly proportional to concentration. Suppose if you want to compare the two osmotic pressure, you can write the formula as pi 1 divided by what? Pi 2. First osmotic pressure divided by second osmotic pressure. So since osmotic pressure is directly proportional to concentration, therefore you can write C1 by what? C2. So first osmotic pressure pi 1 is given as 4.91. Second osmotic pressure is 1.5. C1. C1 means concentration of first solution. So here concentration of first solution is not given. So first you have to find out C1. So concentration means molarity. Molarity of solution is M1. I will call that as M1. So what is the formula for molarity? Mass of solute divided by molar mass of solute into 1 by volume of solution in liter. Since volume is given in liter, so I am not taking 1000 in the numerator. So WO2 means mass of solute. So solute here is glucose, that is 30 gram. And you know that for glucose, molar mass is 180 into 1 by volume is given, that is 1 liter. So after simplification, you will get first concentration as 0.166 mole per liter. So now you substitute here 0.166 divided by, you have to find out the second concentration. So after simplification, you will get C2 value as 0.05 mole per liter, also called as 0.05 molar. So 0.05 molar is there in option C, second option. So therefore question number 30, option B is the correct answer.